It's a great pleasure to be here today and speak to such a knowledgeable group of people who work for a long time in the geospatial industry. I have been about 20 years working on different aspects of it, from a user perspective, where I touched systems like Esri, Intergraph, Geomedia services at that time, MapInfo and so on. I used to work for a while for Oracle, focusing as a sales engineer on the spatial side, and now for a bit more than 10 years I'm at Microsoft. And during the whole time my ambition was to make geospatial technologies more accessible, more interesting, more engaging, more part of everyday's life, and useful for everybody. I think we have come a very long way down that road, and I want to give a little bit of my perspective on where we come from, where we are today, some of the things, how a lot of the technologies are influenced by geospatial technologies at Microsoft and in general, and then a bit of perspective on where we might be going in the next few years. So there was my challenge with technology, more on the presentation side, hopefully. Yeah, so we have been since tens of thousands of years obsessed by location, right? And we talked today about fast food restaurants. We talked about you know, some of the dating sites where you got the bikinis or so in the advertisement. That has always been one of the drivers, right? Where do we get food? Where do we find the nearest tribe that we have there? And as we learn more about the world, our understanding, our precision of what we are displaying also changed. 1492, the year when Columbus basically visited for the first time parts of America. The globe made here in Germany wasn't even displaying anything of America, right? It was in the year Columbus hadn't returned yet, so it was completely missing. Now, with the digital age, the acceleration of the innovation has also increased. So we are looking at you know, a map from 1993 when Microsoft started to have some geographic representation in Encarta. And then in SQL Server in 1998, we had some terabytes of aerial images that we surfaced there. And then the real breakthrough, I think, for what we see today, and that laid the foundation where we are, happened in 2005 when, you know, certain web technologies became suddenly available and made it more accessible to look at websites and interactive to look at websites and change the user behavior that we have when we click through. At the same time, Google Maps and at that time Bing Maps was called Virtual Earth came around, and suddenly high-value aerial images became available to everybody. That was something that was locked away until then, and suddenly it became available to everybody. Now, meanwhile, technology has further proceeded, and the content is more accurate. It provides more level of detail. We have 3D models, for example, that you see here today in some of the Google technologies, in Bing Maps and Esri technologies, and so on. And lots of this is fully automatically generated. We built in a practice in Graz large-scale digital area cameras, and we can capture high-resolution photos while we fly along. And then in a more or less fully automated process, we can generate these 3D models without manual interaction. There are a few exceptions, for example, when it goes to overpasses and underpasses and bridges, for example. But this thing with the Colosseum in Rome, there was no manual interaction, for example, required at all. Capturing roads from the street side is also one of the things that became increasingly popular. And much of this is nowadays even something that you find in a lot of open data today. And with open data, I don't only mean OpenStreetMap with a community of you know, hobby mappers that, and enthusiasts and you know, non-governmental organizations that help in the HOT-OSM, the humanitarian OpenStreetMap team, to map out the world where it is most vulnerable. But I'm also thinking about some of the higher value chains. Open aerial map is being revoked again. We have some of the street side imagery that is being crowdsourced through services like Mapillary today. So there's a lot of things that happens even in that front. All of this is something that people back in 2005 until and even until today pay some amount of money for to have access to these web maps. On the other side, it becomes almost like a dial tone feature that you expect to see in a lot of products. You expect that your database today is spatial enabled and yet you can do spatial analytics on it. You have an operating system, no matter what it is, a Mac, an Android, an iOS, or Windows device that must have some form of maps on it and that needs to be aware where you are and give you better information. Even your development environment needs to be enabled to simulate location information if you build mobile applications. Let me give you a few examples of how basically some of these location technologies that we built have made it into the product. So we have a lot of new ways how we interact with these technologies. We look at some of these personal digital assistants, we talk to them, tell me how long it takes to get home, what is the traffic situation in Bethesda, and we expect that it comes back and shows us a map. We want to be able to ink on a map canvas today and share this information out via OneNotes, via emails that we want to send to others to describe exactly where we meet. But we need to do that also in a way that is accessible and meaningful in the device that we carry with us. For example, if we have a small device like an Android watch or the Microsoft Band, it would not be very helpful if we have a highly detailed map there. We need to have something that is readable at a glance and that perhaps even gives us to haptic feedback a notification when we have to turn left or right. We think about things like indoor maps, old hat meanwhile, right? Everybody has it. We need to think about the next step, and as we heard today in the morning from our speaker from Intel, there's lots of ways how we're getting close to provide indoor navigation. Maybe in a hotel like this one, not necessary, but if you have to travel through a train station in Tokyo, you probably would appreciate if you have a three-dimensional navigation system indoors, especially if you don't speak the language. Now, and if we think about the physical and mixed worlds, our representative from Trimble mentioned the HoloLens, for example. This is one of the new environments that we get to experience. And I must say, I was fortunate enough to see one of these things in one of the public safety scenarios where it was shown, and it was amazing. It was really the most impressive piece of technology I've ever personally experienced. To see something in front of you and have this like a three-dimensional environment and yet interact with all the people that may or may not be in the room. So this was an amazing experience there, and it is something that you cannot describe in words or grasp if you just see the video. But you can imagine if we think about virtual tourism, if you think about firefighting, maybe not in the 700-degree temperature, but if we think about how do you get through, for example, one of these oil rigs to the place where you basically need to actually extinguish the fire, if you need to find out where the vents are that you have to close off, if you need to see when you have a hostage scenario, for example, what is the most covered way to approach this building, then these sort of things in the planning phase, they are immensely helpful. We have a lot of scenarios where we track from advertisement to scenarios where we have the more intentional the tracking of things that we want to geocast as a live video stream connected to my GPS feed, to perhaps my service engineers that I need to find out who can be the quickest one at a certain customer that has an incident there, to even Santa, right? And the quality of the data that we need to have to track him, trucks or the service engineers, is certainly different. If I need to think about something that should represent the video feed, I need to have a fairly accurate representation of the map as well. If I think about Santa, who is flying at 20,000 feet and only going down from one city to the other, I probably don't need to have the entire world in high-resolution images available. Now, a lot of the scenarios that we have talked about go into some form of decision support, business intelligence, location intelligence that surface on a map. And be it something that we have as, these density maps that you see there that show you now traffic accidents in Seattle, where you can clearly pinpoint where the crossings are that have a higher rate of incidents there, to some thematic maps that show you where we have, renewable energy by state, what the percentage of that is. So we see the Pacific Northwest, a wonderful place to live. This is one of the things that you just expect to be there. A few years ago, You would go and say, okay, if I have, a table that shows me some of this data in Excel, that's fine. But now I want to show that perhaps even in the context of a time scale. I want to, and I will come back to the time slider in a moment. If we think about all the ways how maps can help us to help, I mentioned the humanitarian OpenStreetMap team. This one is an example where the National Geospatial Intelligence Agency was analyzing after the earthquake in Nepal satellite images to identify where the destructed areas are, which roads are passable, and then they made it available through a number of systems, including through their own website, so that the helpers could actually find how they get to the place and which one they can prioritize. That's a wonderful way how we really make use of a map today. So here we have this example with the time slider coming back to that location intelligence. We bring some form of meaning to a huge spreadsheet that we have here that described a lot of building permits that we had over time in Seattle. And you saw the recession there, nothing much happened. And then when it came back, there was a lot of activities that popped up there. Similar, we can use it to identify issues. 911 incidents in the city of Seattle. So that is very intriguing. So we have a large spike here. I can drill down and we find there's liquor violences is one of the top crimes that we apparently have here, or 911 calls at least that we have there. And we can then pin that down to exactly the bar that must have an amazing business to generate that many. Some of you may have heard about PowerBI. PowerBI is a service that is partially free. It taps into many content packages that we have from things like your OneDrive where your spreadsheet might sit, and you share it out with your co-workers or the public depending on who you want to grant access to that. Now the way how you usually represent that is through some form of dashboard. But these dashboards become interactive. There is a machine learning algorithm that actually tries to understand the data and allows you to pivot them through just a sentence, a question on the fly. So the default view of this retail dashboard that you see on the left-hand side is what you see there. And then I type in the search box on the top, now show me the stores by revenue on a map. And then it will choose the chart based on the semantic, on the sentence that I have given him, and shows me in this particular case sized bubbles. So these form of semantic analytics that allows you to ask pretty much any questions that you have in mind, and then the system tries to understand, comprehend what you want from it, and delivers the best data back. Now, some of the random thoughts to finish up what I think we will see more in the next few years. Any form of these user experiences, be it these mixed worlds, virtual reality, augmented reality, holographs that we have here in this table, I think how we interact with computers will change. My daughter can today work with a tablet, she's 4, better than my parents can use a computer. That's amazing, right? So she doesn't know how to use keyboard, but because she can talk and touch this computer, she can already at the age of 4 interact with it. We see a lot of new devices and scenarios, and we talked about some of those today: indoor navigation, smarter watches that we have there, even the cars that you see here that drives themselves. Those will need different types of data. So if we want to show just, the renewable energy by state, I don't need to have lots of data. OpenStreetMap is way good enough for a representation like that. If I want to do something like a self-driving car, I need to have a near real-time map with networked cars and the sensors that stream a lot of information in there. So this living map is something that we don't have yet. It is something that we still need to build. And there will be challenges for each of those, right? What happens when the first of these self-driving cars drive over a dog, or worse, over a person? Whose fault is it? The software company, the car manufacturer, or the driver, who, at least according to German law, always needs to be in control of the car? You can change the law, of course, but that brings other challenges with it. Today we had news, for example, that firefighters in California couldn't approach one of the sites because a drone was in their way, right, and they had to turn around. We have these incidents happen today. We will have a lot more personalized experience. My photos, my street side experiences in a map, rather than whatever a driver from Microsoft or Uber or Google might have seen a year ago. But there's privacy issues that we need to address, of course, right? A lot of them. I might be happy to share that for data that is represented to me, but not necessarily for data that is represented to the rest of the internet. And I think open source and open data is a huge opportunity. I have been fortunate enough to attend some of these conferences on the governmental level. I was on the State of the Map conference in New York recently. There is a lot of innovation that goes on there. Innovation that drives new data types, new data formats, new map controls in there. And we cannot really jump on every of these fashions and trends, but we need to embrace the change and filter out, try to filter out what will actually determine how the future will look like. D3, the data-driven documents, for example, is a standard way of data visualization today. Cesium is a WebGL implementation of the world that is used by the National Map of Australia, for example. It's fairly new, spin-off from AGI nearby here, and is now used on governmental institutions. We need to understand what's happened there. There's things like CZML, that is for time animations in the cesium control. There's things like 3D vector tiles that came out for cesium just today. And we need to understand, do we need to follow these trends or not? There is so much, we almost can't understand and grasp and learn it all that is out there. So we need to work as a team and try to understand, at least that's what we try to do, to embrace these, to contribute, and to participate in the open community as well. This is, by the way, one of the experiences, a little bit older, how you saw the self-made street side images with the Mapillari. This is, my car on the way to my house. There is nothing else that Google provides there. This is very personal experience. And with that, I thank you for your time.